This is Retrofitting 101 by yours truly, Dave Cyril Morcilia. I will give you a preview regarding what you'll expect in this video. First, we are going to tackle about the meaning of retrofitting, role of loads in causing damages and failure of structures, special consideration when retrofitting historical structures, general retrofitting approaches, material-specific retrofitting approach, which will include stone or brick masonry, timber structures, reinforced concrete structures, and steel structures. We also have some segments like prevention is better than retrofitting, base isolation, and if I can, retrofitting my house. First, ano ba pag sinabing retrofitting? Retrofitting refers to the addition of new technology or features to older systems. Take note that in this video, we are going to talk about how we retrofit civil engineering structures. Civil engineering books refer retrofitting to different strengthening interventions that were able to restore an acceptable level of safety the existing structure once had. Sa pagre-retrofit, hindi tuluyang pinapalitan ang kabuuan ng structure at gumagawa ng bago. Dito, pinananatili pa rin hanggat maaari ang mga bahagi ng structure na pwede pang magamit kung magagawa ang pagpapatibay o pagsasaayos nito. Sa madaling salita, ang retrofitting ay tumutukoy sa paraan o mga paraang ginagamit upang muling mapatibay ang isang building o structure. Bakit sinabing muling mapatibay? Sa buong panahon na nakatayo ang isang structure, makakaranas ito ng tinatawag na mga loads o dalahin. Nakahati ito sa dalawang kategorya, dead loads at live loads. Dead loads are loads of constant magnitude that remain in one position. These include the weight of the structure under consideration as well as any fixture that was permanently attached to it. Ito ay ang mga permanenteng dalahin na kailangang matiyak na kakayanin ng isang struktura sa buong panahong ito'y nakatayo. Live loads, on the other hand, are loads that can change in magnitude and position. They include occupancy loads, warehouse materials, construction loads, overhead service cranes, equipment operating loads, and many others. In general, they are induced by gravity. Ang mga ito ay ang mga load na nag-iiba-iba at hindi permanenteng bubuhatin ng structure. Loads caused by typhoons, earthquakes, and other natural phenomena were called environmental loads. Environmental loads, due to their nature of being seasonal and changing, are also treated as live load. Among all the loads that a structure will encounter through its lifetime, earthquakes are considered the most predominant cause of damage and oftentimes cause loss of lives and property. Due to the nature of earthquakes' dynamic horizontal and vertical movements and other secondary effects like landslide, it was most expected to cause evident damage in any structure. Eventually, retrofitting is immediately considered when a structure suffered minor structural damage such that they can still be considered safe if treated so. Bagamat nakadesenyo ang isang istruktura na kayanin ang mga loads nito, hindi pa rin maiiwasang mayroong mga factors o bagay na nagiging dahilan ng paghina o kung hindi man ay tuluyang pagkawasak nito. Minsan, ang dahilan ng paghina o pagkawasak ay dahil sa maling paraan ng pagkakagawa o construction ng istruktura. Ito ay bunsod ng human error at poor materials quality. Kung hindi naman ang pagkakagawa ang dahilan, nauuwi ang problema sa pagkakadesenyo o pagkakaplano sa istruktura. Dahil na rin sa mga nagdaang karanasan at mga pag-aaral, nabuo ang mga tinatawag na codes o kodigo na siyang pinagbabatayan sa kasalukuyang sistema ng pagdidisenyo at construction. Sa Pilipinas, ang sinusunod na code ay ang National Structural Code of the Philippines o mas kilala sa abbreviation nitong NSCP. Bago natin pag-usapan ang mga paraan ng pagre-retrofit, mahalagang maunawaan natin ang mga kategoryang kinokonsidera sa pagsasagawa nito. Unang tinitingnan ay ang historical significance ng nasabing struktura. Sa nagdaang panahon, bago lumabas ang mga code ay rule of thumb at pamanang karunungan ang pinagbabasihan sa paggawa ng mga gusali. Kasama dito ang mga lumang materyales na bihira ng gamitin sa panahong kasalukuyan. Most of the time, historical structures are damaged due to wars, passion, and time. Bagamat halos pareho ang konseptong isinasagawa sa pagre-retrofit ng mga historical structures at ordinary structures, there are obvious differences with regards to consideration of materials and approaches that were used. For historical structures, we are to follow the so-called conservation codes like the ones from UNESCO and rules set by some governing bodies. Here in the Philippines, we have the National Historical Commission which must be consulted before conducting any retrofitting jobs in any historically significant structure. Here are some of the main rules followed internationally regarding the retrofit of such structures. First, implement conservation works instead of restoration works. Respect the original material, and every new material used for integration should always be recognizable. Every reconstruction work should be ruled out a priori. Only anastomosis may be permitted. Compatibility and durability of new materials should be assured. Invasivity of the intervention should be avoided. Provide recourse to sciences and techniques which can contribute to the safeguard of the structure, but the application should be proved by experience. Reversibility, or the possibility to treat again, should also be searched. In general, most, if not all, strengthening and retrofitting jobs fall on the following approaches. 1. Adding new structural elements. 2. Strengthening existing elements. 3. Locally increasing the deformation capacity. 4. Introducing isolation systems. And 5. Reduction of demands. Adding new structural elements is a basic approach that relies on the insertion of additional elements reacting to horizontal or vertical action. Para sa building structures, the addition of new structural elements may consider the use of steel-braced frames dahil madali itong ikonekta sa mga concrete or steel buildings. Sa ganitong paraan, hindi naman kinakailangang tuluyang tanggalin ang mahinang bahagi ng struktura. Magsisilbing suporta o dagdag na tulong lamang ang mga ito upang maiwasan ang tuluyang pagbigay ng nasabing bahagi. Dahil nagdagdag tayo ng bagong structural member, ang mga nadagdag na structural member ay tiyak na magdudulot ng panibagong loads at distribution of forces na maaaring makaapekto naman sa lower members hanggang sa foundation. Dahil dito, kinakailangang pag-aralang mabuti kung papaano ito makakaapekto sa bahagi at kabuuan ng structure. Kung hindi lubos na aplikable ang pagdadagdag ng bagong structural member, dito pumapasok ang isa pang approach, which is the need for strengthening existing elements. This is the application of capacity design principles to reduce the likelihood of brittle failures. Some of the well-known examples for this approach includes jacketing, which either use concrete, carbon or glass fibers, or steel plates to cover the structural member and provide additional strength to prevent shear and flexural failures. Locally increasing the deformation capacity is mainly applied if all possible brittle failure modes have been eliminated by a proper application of capacity design principles. Halimbawa, sa mga reinforced concrete structures, maaaring balutan ng steel ang isang column to help reduce the risk of bar buckling and increase the compression deformation capacity of concrete. Although it would naturally be expensive, the insertion of an isolation system at the base or at some height of the building can often be a last recourse intervention to improve the seismic performance of a building. The key issue with existing structures is the possible technique to insert the isolation system and consequently the problems related to the relative movement between the isolated part and original part of the building. Gayunpaman, available naman ang mga gamit at teknolohiyang kinakailangan upang ito ay maisagawa. Although the general idea with regards to retrofitting is the need for giving new or additional strength to a member, the same is true, but the problem can still repeat if previous loading conditions will still be encountered. In this case, reduction of demands can be considered. In some steel frame structures, the addition of dampers were used. Bagamat di gaano nakasanayan o masasabing direktang paraan ng pagre-retrofit, ngunit ang paglilimita sa mga loads o demand ay isa pa din sa pinakamabisang paraan upang matiyak na hindi masasagad ang capacity ng ni-retrofit o ng previously damaged structure. Sa pagkakataong ito, we are going to tackle some of the common retrofitting methods used at different kinds of building based on their material composition. First, we have stone and brick masonry structures. One of the most common problems encountered with this kind of construction is the tendency of crack formation. For this kind of damage, crack stitching can be used. The general idea of crack stitching is to introduce steel bars in between bricks or stones that will act as connecting bones of the structure. We have this short clip from Brickfix that will illustrate us how crack stitching was executed on masonry walls. Unang ipinapakita ang kasangkapang ginagamit sa crack stitching. Sa pagsasagawa ng stitching, unang ihinahanda ang paglalagyan ng metal reinforcement. Gumagawa ng butas sa pader sa pamamagitan ng grinder at pwede rin gumamit ng mortar chisel. Sunod na nililinis ang nagawang butas at pagkatapos nito ay ihinahanda ang gagamiting grout. Kaya tinawag na crack stitching ang pamamaraang ito ay dahil maihahalin tulad ito sa pananahi ng napunit na damit kung saan ang nagsisilbing sinulid ay ang metal reinforcement at ang grout na magsasara sa bitak ng structure. Pagkatapos maihanda ang grout, muling lilinisin ang butas sa pamamagitan ng tubig at dahan-dahang ilalagay ang grout sa loob nito. Pag maayos na ang paunang grout, maaari nang ilagay ang metal reinforcement at muli itong papatungan ng isa pang layer ng grout. Maaaring magdagdag ng metal reinforcement ayon sa pangangailangan ng masonry wall. Ang crack stitching ay maaaring gawin kahit sa mga sulok na kinakailangan ito. There are some instances, on the other hand, that some masonry walls are being displaced due to ground deformations, weak wall foundation, and weakened bond as time goes by. Some will only be evident, especially after an earthquake. To address displacement, the introduction of reinforced wall footing would initially be considered, while wall tying was commonly used if the problem lies with the wall itself. Hindi lahat ng displacement na maaaring mangyari sa isang masonry structure ay vertical. Some are diagonal and some are horizontal, as you can see in this picture video. Ipinapakita dito kung gaano kalaki ang naging displacement ng brick wall sa original na position nito. Here, as you can see, the wall was slowly lifted hanggang sa naglapat muli ang na-displace na bahagi ng wall, although sa nakikita nyo ay pinas forward ko na ang bahaging iyon. Bagamat hindi na ipinakita sa video kung paano ginawa, hindi maitatangging inayos muna ang pundasyon bago tuloy ang inalis ang mga pansamantalang suportang ginamit. Isinasagawa ang wall tying sa pamamagitan ng pagkakabit ng mahinang dingding sa mas matibay na dingding o sa anupamang structural member. Sa bidyong ito, ipinapakitang binutasan muna ang magkatabing dingding at matapos nito ay sunod nang ilalagay ang metal reinforcement. Ang ganitong paraan ng wall tying ay karaniwang ginagamit sa mga historical structures dahil less invasive ito at hindi gaanong mahahalata. Minsan, ang paggamit ng steel ties at steel bracings ay mas inirerekomenda kumpara sa paggamit ng kahoy dahil mas matibay ito at kumukonsumo lamang ng kaunting espasyo. Ang dapat lamang tandaan ay ang tamang pag-aangkla nito sa masonry wall dahil may mga pagkakataong nabubutas ang pinagkabitan ng angkla dahil sa mahinang distribution of force. Isa sa pinakalaganap na kasangkapan sa paggawa ng mga estruktura ay ang kahoy o timber. Bagamat maganda at matibay na kasangkapan ang mga gawa sa kahoy o timber structures, isa sa pinakakahinaan at nagdudulot ng pagkasira nito ay ang pagkabulok, pagkaanay o pagkabukbok at paghina sa pagdaan ng mga taon, lalo na kung hindi magagamot bago gamitin. Kumpara sa ibang mga materyales na ginagamit sa paggawa ng struktura, ito lamang ang nagmula sa buhay na bagay kaya't hindi maiiwasan ang pagkabulok nito. Isa sa pinakakaraniwang gamit ng timber in structural aspects of a building includes its use in truss systems. Evident ito sa mga lumang structures at maging sa kasalukuyang panahon ay ito pa rin ang mas pinipiling gamitin lalo na sa mga bahay. Timber commonly crack due to non-uniform transfer of loads caused by changes in moisture content and improper or poor connections. Some interventions include the use of timber wedges to help correct or adjust contact in order to help force distribution. To further improve connections and capacity, metal devices were also introduced. Although helpful, these connections must be designed carefully to ensure proper incorporation of the new material in the previous one. Ang maling pagpili ng laki ng bolt o pako at paraan ng pagkakabit ang nagiging dahilan upang lalong humina o masira ang isang timber member. There are some instances, on the other hand, that a certain member or some parts of it cannot be used further and requires changing. As you can see in this featured video, some member ends were already missing or decayed. In these cases, the introduction of properly cut prosthesis or scrap joint or scrap rafters can be considered. Therefore, this would not require the changing of the entire structural member. In the analysis of trusses, Forces were considered acting concentric to the members, while connections act as pins. In the actual application, this does not happen most of the time, causing deflection of the member. Highly deflected trusses can be reinforced with the use of metal tendons that will balance flexural forces acting within the structural member. Some engineers reinforce these members with deformed bars. On the other hand, steel bracings can also be considered as seen in this featured photo. This method is also applicable for timber beams and girders. Nailing roof trusses on timber ties that connect the vertical load-bearing walls of the building, masonry or timber frame improves seismic resistance. Reinforced concrete is one of the most widely used construction material nowadays. Like any other material, it has disadvantages that commonly cause structural failure. Concrete is reinforced with steel bars due to its high compressive and low tensile strength. Most long-standing reinforced concrete structures fail only during an earthquake. This is the reason why building codes include seismic analysis in order to prevent collapse or to lessen structural damage. A commonly adopted technique that aims at increasing the lateral stiffness and strength of a specific story or overall structure consists of adding steel bracing systems to the existing reinforced concrete building. One advantage of this strengthening technique is the reduced impact on foundations, especially if compared to other design solutions such as the use of reinforced concrete shear walls. For concrete structures, especially on columns, the use of jacketing as mentioned in the earlier part of this video is the most commonly used technique in retrofitting this structural member. Jacketing is a method of retrofitting that basically uses concrete and/or steel elements to cover weak or weakened columns such as to provide additional load-bearing capacity. In the following video from Horse Construction, execution of modern-day jacketing was explained. Take note that this is only one of the methods used to execute jacketing. Let's watch.
Construction process of structural perfusion adhesive. Remove surface coating until concrete surface appear. Make it clear and sound. Grinding surface smooth and chamfer angles. Repair and level concrete defects with force repairing adhesive. Locate the setout according to the drawing. Grind and roughen adhering surface of angle bar and batten plate. Install gasket, clamp steel skeleton with special fixtures. Leave 2 to 3 mm gap between steel skeleton and original member. Weld batten plate and steel skeleton. Weld should be straight, uniform, no virtual welding, leakage welding. Embed injection nozzle and exhaust hole according to design. Seal gaps between angle bars and batten plates with horse crack repair adhesive. After crack repair adhesive is cured, test pressure with air, and if there is leak, seal it in time. Mix the horse structural perfusion adhesive according to the ratio. Mix and stir evenly. Avoid bubbles. Do not mix too much adhesive once to avoid waste. Inject horse perfusion adhesive via injection nozzles with low pressure. Stop injecting when the adhesive appears in the near exhaust hole. Seal the exhaust hole and keep injecting adhesive with low pressure for 10 mins. After adhesive is cured, remove injection devices and extra adhesive. 72 hours curing and maintenance time is needed after injection construction. Check if there is hollowness after adhesive is cured. Finally, apply anti-corruption and anti-fire coating. Horse Construction, high-end structural strengthening material specialist.
A beam which starts to sag can either be retrofitted by the addition of structural steel bars that will act as columns. Steel plates and bracing, on the other hand, can be used to provide additional connections between accidental discontinuous members and to provide additional flexural strength to the beam. Concrete jacketing principle for this kind of member was not the most ideal because of the comparable difference with steel strength and concrete strength. Aside from higher additional self-weight, discontinuity between old and new concrete can cause further sagging of the beam or, if not, sudden failure. Grout or epoxy injections are used for instances that honeycomb, hollow areas, voids, or cracks were found within any concrete member. The main difference of steel structures to other kinds of structures would be its high compressive and high tensile strength. Steel structures can also experience failures, but careful considerations can greatly minimize such risk. Because the steel was made up of metals, the main disadvantage of steel would be its corrosion-prone property and its high heat expansion coefficient. The use of anti-corrosion and fire-resistant materials should be considered not only after retrofitting, but especially during design and construction. Damaged structural members can easily be repaired by welding new elements or by changing the entire member with a new, stronger one. Same as pour and porous concrete structures, retrofitting this kind of construction can include the addition of new structural elements and introduction of bracing and damping systems. Mayroon tayong kasabihang prevention is better than cure. Para sa ating mga engineers, prevention is better than retrofitting and failure. Napakahalagang sa pasimula pa lamang ng pagpaplano at pagdedesign ay natiyak na nating ligtas at mananatiling nakatayo ang ating struktura, ano pa mang unos ang dumaan dito, habang kasabay na kinukonsidera ang tinatawag nating ekonomiya. Sa bahaging ito ay ating mabilis na pag-aralan ang lohika at teknolohiyang ginagamit sa base isolation, na isa sa pinakamabisang paraan upang maiwasan ang malaking pinsala na naidudulot ng lindol sa isang struktura. Ang bansang Japan ang isa sa mga pioneer at malawakang gumagamit ng teknolohiyang ito. Bagamat masasabing malaki ang magagastos sa pagpapalagay o pagsasagawa nito, kung susumahin ang halaga ng pagpapagawa sa mismong structure at ang halaga ng buhay na maaaring mawala sa panahon ng sakuna, maliit na bagay lamang ito. Narito ang isang maikling dokumentaryo ng OPB organization tungkol sa base isolation.
Ishinomaki Red Cross Hospital in Japan took the full brunt of a magnitude 9 earthquake. But the hospital survived without so much as a broken window. That's because the hospital was built on a hill beyond the tsunami zone. And during the quake, the entire building floated on a cushion of springs. Jay toured the hospital with Dr. Chris Goldfinger and Allison Perch. This was seismic engineering unlike anything they'd seen in Oregon.
So, can you explain the system to me?
Inside, there is a rubber isolator which consists of 26 layers of rubber and iron sheet. It is structured to prevent the hospital from getting damaged in the earthquake by suppressing the vertical shaking and shaking sideways.
Base isolation is now in wide use across Japan, but in the U.S., it's California that's taking the lead. Engineers at UC San Diego built this mock hospital to California's highest seismic standards, but then they tested it with and without base isolation. With base isolation, the hospital rolled through even the most violent motions. Without base isolation, the building stands, but the damage is severe. Base isolation is expensive, and in Oregon, it's not required in hospitals, even in earthquake zones. Jay insists it's a model for the future.
The payoff for that big hospital in Shinomaki is it worked. It continued to deliver in the worst case scenario because they built it above and beyond the minimum codes.
So hello po, nandito po tayo ngayon sa aming bahay at ipapakita ko po sa inyo ang mga parte ng bahay namin na kailangang ayusin o sabi nga natin ay retrofit. So ang una nating i-assess ay yung naging sira sa bubong namin. Bale nitong nag-quarantine lang namin siya napansin, so hindi namin alam kung kailan siya exactly nasira. Kung mapapansin nyo, yung sira sa member na ito ay sa padulo, lalo na dito sa may parteng koneksyon. Ang nakikita kong dahilan ng paghina niya ay yung mga anay, kasi kita pa yung mga lupang dinaanan nila sa loob. Tapos isa pa din yung itsura ng grains niya, kasi evident na binubukbuk na din yung bahagi ito. Ang unang solusyon kong naiisip ay tingnan kung magagamit pa yung pagitnang bahagi ng member na ito. Kung lalabas na okay pa siya at hindi pa napapasok ng anay or ng bukbok, ay pwedeng i-apply natin yung paglalagay ng bagong kahoy na ikakabit sa katawan nito. So, hindi mangyayari totally yung pag-aalis ng member natin. Ang second solution naman ay yung pagpapalit na mismo ng iba pang mga member kasama tong member na to sa kabuuan ng bubong. Ang problema kasi sa ganitong kaso ay yung posibilidad na hindi lang ang member na ito ang inaanay at binubukbok. Maaring hindi pa lang nagpapakita ng pagkasira yung iba, pero hindi maitatangging ang posibilidad ng pagkukolaps ng buong bubong kung hindi maagapan. Ang mahirap kasi sa kahoy na ginamit dito ay yung kakulangan sa pagtitreat at curing sa kanya. Yung pagpipintura man lang ng varnish ay isang magandang paraan sana upang maalagaan ang kahoy, kaso sa lagay nito ay baka hindi naaabot kasi malaki ang posibilidad na napasok na yung iba. So nonsense na yun kung ngayon pa lang siya lalagyan ng varnish. So wood lang kasi ang kahoy na ginamit dito galing sa niyog compared kung galing siya sa hardwood na sabi nga, ang pinaka magiging pangunahing sanhi lang ng pagkabulok ay kung laging nabababad sa tubig. Kung may pera lang ako, kaya nga ang title nitong segment na ito ay If I Can Retrofitting My House, ay totally papalitan na namin ng steel truss. Pero alang-alang sa budget at sabi nga ay retrofitting ang subject na ito, pwedeng ang gawin sa kanya ay paghiwalayin yung mga members na masasabi pang safe or yung hindi pa talaga napapasok ng anay at bukbok. So pag na-assess kung alin yung talagang hindi na pwedeng hindi papalitan sa pwede pa, ay saka isa-isang papalitan yung mga damage na, tapos pare-parehong gagamutin o babarnishan yung buong bubong para hindi na siya pasukin ng anay or hindi na siya mapasok din ng bukbok. Ngayon, ang sunod naman nating titingnan ay yung cracks na lumalabas sa kwarto ko. Kung mapapansin nyo dyan sa video ay parang malalaki yung mga bitak, pero dulot lang yan ng lighting ng hiniram kong camera kasi hindi naman siya sobrang laki kung sa actual. Bagamat obvious pa rin siya dahil kita siya dyan sa video. Kung makikita nyo yung kanyang katawan ay hindi pa naman siya humahapay or nagbabaw. At sa sahig ay wala namang bitak, so indication siya na hindi siya major structural damage. Sa palagay ko ay bunga lang ito ng shrinkage ng ginamit na concrete dahil by segment yung bitak niya, lalo na sa pagitna. Dahil yung naging sentro ng web ng crack ay yung, syempre, yung nasa gitna. Tapos dahil hindi pa naman tapos ang bahaging ito ay pwede na ang paglalagay ng kaunti pang grout or epoxy at saka dun pa lang lalagyan ng finish. Ngayon, kung sakaling lumindol ulit o kaya ay may kung ano pa mang mangyari at mas lumaki tong bitak, meaning hindi shrinkage ang problema. Kung dun sa lindol, pwedeng gawin dito yung wall stitching na ang ilalagay na horizontal beam ay kahit deform bar na lang na mas matibay sa original na ginamit sa kanya. Kaysa bibili pa nung pinakita sa video kanina, bagamat mili, sa masonry walls yung ginagamit or ginagawa. Kung ang magiging reason ng mas malaking crack in the future ay dahil humina yung lupa, alamin muna kung mayroon bang kahit kaunting wall footing ito or totally wala siya simula pa ng construction. Tapos, saka i-consolidate yung lupa, patitibayin yung lupa at lalagyan ng wall footing yung dingding, tapos dun pa lang siya pasisimulang stitch ulit pataas. Ang last nating i-assess ay itong parteng pinagtatagpuan ng dingding namin sa malapit sa pintuan. Ang kaso kasi niya ay nagpapakita ng crack yung bahaging pinagsalubungan nila. Kumpara sa ibang sulok ng bahay, dito lang naman merong ganitong crack. So, pinapakita lang nito na hindi siya totally na magkadikit or mahina yung connection. Maaaring dahil sa kulang or walang steel na ginamit para ma-secure sila o mahina yung bonding ng concrete na ginamit sa area na to. Depende na lang sa direction siguro nung kung lilindol man o babagyo, kung saan man yung papunta yung pwersa, ang magiging paraan ng paghapay o direction ng paghapay ng alinman sa dingding na to. So, ang nakikita kong solusyon ay ang paglalagay ng column sa kantuhang ito. Ang unang paraan ay ihahalo muna yung kantuhan tapos ay saka maglalagay ng column, or yung ikalawa naman ay pwedeng hindi na siya totally ihalo, kundi sabi nga katulad lang ng concrete jacketing, ang magiging pinakapagkakaiba lang ay ihuhugis lang yung concrete dun sa mga corners. Maalin man dun sa dalawa, ang pinaka magsasara ng connection ay steel bars. Ang naging sistema kasi sa pagkokonekta nito sa ngayon ay doon sa bottom cord ng truss at ties, ikinabit yung dulo ng steel truss ng steel bars na humahawak sa dalawang dingding at hindi na nalagyan ng hiwalay na steel reinforcement na magsisecure doon sa connection ng magkakabit na dingding. Kung babalikan yung naunang video ay matatandaan yung inaanay na yung member na ginamit at dyan sa area na yan tumutulay yung anay. So, nasira din yung pinagkakabitang kahoy kaya naging loose na yung connection ng wall sa ties na posibleng yun ang naging dahilan kaya humina yung area na to. At sa buong parte ng bahay, ito lang yung may ganyang uri ng crack. So hello po sa ating lahat, nandito po tayo sa aming bahay at ipapakita ko po sa inyo ang mga parts na kailangan i-retrofit. So hello po, nandito po tayo ngayon sa aming bahay at ipapakita ko po sa inyo ang mga parte ng bahay namin na kailangang ayusin o sabi nga natin ay i-retrofit. Yun na lang kaya. Huwag natin na, baka sumikat ako.
Hindi boto ni Muhammad Ali.